Let's test the transaction class. For our tests, we'll make sure that a new transaction that we create with the new transaction function creates the relevant outputs. One is the resulting amount of the sender after the transaction. The second one is the amount of currency a recipient receives from the transaction. To test the transaction, let's create a new file called transaction.test.js within the wallet class. That's transaction.test.js. To test the transaction class in this file, first of all, we'll need access to the class itself. So let's create a transaction constant that is the result of requiring the local transaction file. We'll also need to access the wallet class since new transactions are based on a sender's wallet, which means we'll need to create a wallet instance. So we're going to acquire the wallet, which is located at the local index file. With that, we can begin the overall test with the describe function. So let's describe this overall test as the one for the transaction class. And then our callback is an arrow function as the second parameter to the describe function. Right away, let's declare 4 variables that we'll use throughout our tests. First, we'll have a transaction to run our tests on. Then we have a wallet, which represents the sender's wallet, and then a recipient to send to, and then an amount for the transaction. We'll want to create the relevant values before each following test. So we'll use a before each function, which as its one parameter is an arrow function, to call back. The before each function will assign the wallet variable to a new wallet instance. So we'll say this wallet is a new wallet instance with new capital W wallet. The amount can be anything, so how about the arbitrary amount of 50? And then the recipient can be a string of anything as well, so why not the least speak version, or leet speak rather, version of recipient, which is R3, C1, P13, and T. As you can see, it kind of looks like recipient, but leet speak changes certain letters to alternate variations as a way of encoding it. Finally, the transaction object will be set to calling the new transaction function and passing in the wallet, recipient, and amount variables we just assigned. So the transaction is equal to transaction.newTransaction. So we're calling that static method. We're passing in the wallet, and then the recipient, and then the amount within the transaction. So overall, it looks like transaction, new transaction, wallet, recipient, and amount. Great. For the first test, let's make sure that it creates an output with the amount value subtracted from the original balance of the wallet. In other words, it creates the output for the sender. So it outputs the amount. Notice the backticks so that it indicates that amount is a variable subtracted from the wallet balance. And then we have our callback as the second parameter. Within the actual test, let's find the output that matches the public key of the wallet within the transaction. We'll do so by using the find function on arrays, which returns the first element that passes a condition, which in our case is the first output object whose address matches the public key. So we're going to expect that that object, which is the output object we're looking for. So within the transaction outputs, let's find the one that matches the output.address, which is equal to the wallet's public key. So the actual whole function looks like expect transaction outputs.find, look for each output one at a time, and then find returns the one which matches a certain condition, and we're looking for the one whose address field matches the public key field within the wallet. And then we'll expect that this found object's amount is equal to the original wallet balance minus the given amount that we're using for the transaction. So this will return the object. So let's say this dot amount is going to equal the wallet dot balance minus the amount, which is the expected amount for the sender output. So again, you want the amount at the end of the found output object, you want it to equal the wallet dot balance minus the amount. This leads us to now creating the equivalent test, which will check that an output is creating with the recipient's address and the amount that they will receive. So we're going to have a test that says it outputs the amount added to the recipient now, which is the equivalent test, or essentially the opposite test to the one we just declared. So we're going to expect that if we look through the transaction that outputs, and then we find the output whose output.address is equal to the recipient value, well, let's get that amount. So again, look through the outputs, and then this time we're going to find the one whose output address matches the recipient. We'll look at its amount, and then we'll expect that to equal the amount that we're sending to the recipient through the transaction. Great. So that covers creating tests to make sure the outputs match what we should see for the transaction object. So let's run the test with npm run test. Hopefully the tests pass. But as we do so, what we find is an error in the console, and the error, if you expand the command line, says that transaction is not defined because, well, this variable was initially set to transactions. You probably caught that. But then this error this time says that something has not been implemented yet. And it looks like the ec.genKeyPair function hasn't been implemented. Well, the genKeyPair function is actually valid, but it's using a module called broran as a dependency which generates random numbers and is a dependency of the elliptic module. Broran usually expects us to be in the browser context when we're running the JavaScript content, but we're actually executing in Node, which is not on a browser. So to fix this, what we can do is go to the package.json file at the root of the project, and then we're going to add an option called jest, which will tell our jest test runner to specifically run in a test environment, which in this case, the environment will be Node. All right, with the change testing environment, let's rerun the test. So let's close the test and rerun it. And then as we do so, looks like the tests run fine, and indeed all the tests pass if everything goes well. Great. So before we move on, let's add one more test to the actual testing file, which covers a situation where a transaction is attempted to create that exceeds the wallet balance. Recall that we created that handling error, which logs to the console that a transaction exceeds the wallet balance if the amount is greater than that wallet balance, and then it doesn't go with the rest of the function. So to create that scenario, let's describe a new situation where we're transacting with an amount that exceeds the balance. And then this very described block will have its own callback arrow function. It will also have its own before each function. And in this before each function, we're going to set the amount to something absurd like 50,000. There's no way that the wallet has enough currency to send 50,000. And now let's regenerate our transaction object to use this new amount. So we'll say the transaction equals a new transaction dot new transaction. So use that static function. We'll pass in the wallet and the recipient and the amount just like before. And now within this context, we can write a test that says it does not create the transaction as a result. We'll have our callback function for the it test as usual. And then since the transaction new transaction function should return when it gets this absurd value, this transaction variable should be undefined. So we're going to expect that the transaction is equal to the undefined keyword in JavaScript. As we save this, you should find that another test passes, and indeed there's also a log which says that the amount of 50,000 exceeds the balance. Great. So we know that this new transaction function handles extremely large amounts and doesn't execute the functionality. Otherwise, it also does the normal outputs for the sender and the recipient. Let's move on to creating the vital component to this transaction class that at this point is still missing, the input object.